Hello. Today we're going to talk, or in this video, we're going to talk about the applications of continuity. So we've already discussed what continuity is in a previous video. It's basically about having no breaks in the graph. You might recall that there are three criteria of continuity for a function to be continuous at a point. The function has to be defined, f of a has to be defined, the limit has to exist, and furthermore, the value of the limit needs to be equal to whatever the function is defined as. So now we're going to talk about some interesting applications of continuity. Like, what do you basically get out of it? Okay, so I'm going to change over to writing mode. One of the most useful things of a function being continuous is that it allows you to basically move the limit through a composition. So let's just say that f of x is continuous at L, some value L, and that the limit as x approaches a of g of x is equal to L. Then this is what happens. Let's say you have the limit as x approaches a of their composition f of g of x. So notice you have the limit of a composition. Because f is continuous, what you can do is take f of the limit as x goes to a of g of x. And the limit of g of x as x goes to a is L. So what you get is f of L. So the way I like to think of this is that the function f, because it's continuous, can move to the outside of the limit, right? It used to be right here, and now it's outside there. So the continuous function can move through the limit. Let's do an example of this. So let's say that you want to do the limit as x approaches pi over 2 of the cosine of x minus pi over 2. Now I can tell you that cosine is continuous at pi over, it's continuous at x equals 0, because what you need to do is take your pi over 2 and plug it into the inside function. Pi over 2 minus pi over 2 is 0. How do you know this? Because if you remember, what does the graph of cosine look like? Sort of like this. You can see right here at x equals 0 that the function is continuous. There are no holes, there are no jumps, there are no asymptotes. So you can move the limit, you can take the cosine of the limit as x approaches pi over 2 of x minus pi over 2. That inside limit is 0. The cosine of 0 is 1. Okay. So you can just move it through like that. Another very common application of continuity is something called the Intermediate Value Theorem, which is best explained basically by looking at a picture. So we're going to draw a picture to explain this. So here is our axes, x and y axis. And let's say you have some function which looks like this. Okay, so first of all, the intermediate value theorem only applies if f of x is continuous. And we're going to be continuous on the closed interval AB. Okay, so a and b are going to be two x values. So here is x equals a. Here is x equals b. So really we only care about it being continuous between these two numbers. Like what could have happened is that, let's say, you have like a jump over here, doesn't matter because that jump occurs outside of the interval AB. Okay. So let's say that f of a equals some value c. Or no, let's call it let's just call it f of a. There we go. This has some y value f of a. This has some y value f of b. So there are two intervals. There's the interval on the x-axis between a and b. That is bracket a comma b. And then there's another interval on the y-axis between those two y values. That's bracket f of a comma f of b. Okay, so you have these two different intervals. So this is what the intermediate value theorem says. The intermediate value theorem says that you can choose a y value, which we will call c, and c, actually I'm sorry, we'll call it d, in that interval of y values between f of a and f of b. So what I'm saying is choose a y value between f of a and f of b, such as this point right there in red. Okay, we're going to call that d. The intermediate value theorem says that if you choose a y value, d, between f of a and f of b, then there is guaranteed to be an x value called c between a and b, such that f of c is equal to d. So what did we do here? We chose this value d. And if you draw a line off to the side, you can see that there's this point right here on the graph that has a y value of d. The intermediate value theorem is telling us that if you go down to here, there's some x value c between a and b, so that f of c is equal to d. In other words, you started off with these two y values. You chose a y value intermediate them, in other words, between them. And now we are guaranteed that there are, between these two x values, there's another intermediate value, so that when you plug that x value into the function, it's equal to the original y value that you chose. Okay, now you might be wondering, like, why do we care about this? Okay, let's do an example. Use the intermediate value theorem, which we will just call IVT, to show that f of x equals x minus cosine x has at least 1, 0. So remember that a 0 is an x value such that f of x equals 0. Okay, so x minus cosine x is continuous. So the intermediate value theorem applies. F of x minus cosine x is continuous. So the intermediate value theorem applies. If you wanted to, you can graph it. There's some other methods I'll show you eventually so that you can use to show that it's continuous. But for now, let's just say it's continuous. Okay. So what we need to do is, remember the way this works. Let's insert our graph. Is that you need to come up with an a value and a b value. Now what we want to happen is that f of a ends up being negative. And what we want to also happen is that f of b is positive. Because if f of a is a negative number and f of b is a positive number, we can choose any value intermediate them. 0 is between negative and positive. And that means, and the intermediate value theorem tells us that there will be a number between a and b, c, such that when you plug c into the function, you get the intermediate value that you chose, which was 0. So basically what this means is that the graph starts negative and ends positive, which means that it needs to be 0 somewhere in between. So let's see if we can find a value for a. So let's plug 0 into our function. If you plug 0 into the function, you get 0 minus the cosine of 0, which is 0 minus 1, which is negative 1. And you're like, oh, okay, cool. My a is going to be 0. And let's plug in another value. Let's plug in pi over 2. So pi over 2 minus the cosine of pi over 2. Pi over 2 is just pi over 2, but what's the cosine of pi over 2? 0. Pi over 2 is positive. That's our b value. So our b value is going to be pi over 2. So notice f of 0 is negative. That's this point right here. F of pi over 2 is positive. That's this point over here. Now, the intermediate value theorem says that somewhere between x equals 0 and x equals pi over 2, there is a value c such that f of c equals 0, the 0 that we wanted. Why? Because between any positive and negative number, or between any positive and negative y values, zeros between them, the intermediate value theorem assures us of this. Okay, thank you for watching this video on applications of continuity.